Good day everyone, I am Louis Rowe from Group 10. Today our group is going to present about the film Dosimeter. These are the group members in Group 10. In our presentation, we will talk about the working principles of film dosimetry. After that is dosimetry properties. Later, the primary applications of the film will be discussed. After that, we will talk about the advantages and disadvantages. Next, it is about when and why the film dosimetry is preferred. The last part is about the references.
At first, we have to explain overview of film dosimetry. So there are two questions to explain. What is film dosimetry and what is film dosimeter? So talking about dosimetry, film dosimetry uses a special film to measure exposure to the ionizing radiation based on darkening degree of the film. And talking about film dosimeter, it is a small device that can measure, monitor the individual's exposure to the ionizing radiations like X-rays, gamma rays. For an overview, we can see into historical development of film dosimetry. If we see in the 19th century, we can get that evidences that light-sensitive silver halide emulsion and radiographic film, which were used in X-ray technology, were invented in that period. And if you go for early 20th century, we can see that film baz was introduced by scientist Ulam, and densitometers, I mean early densitometers for film darkness measurement were developed in that period. So if we look into mid 20th century, we can see those inventions like radiochromic films and densitometers for quantitative dosage analysis were invented at that period. So in the late 20th century and beyond, that means we can see in a present scenario that digitalization and computer-aided analysis were invented as dosimetry techniques. So now on, we can see that there are so many ongoing research on film dosimetry for betterment of, for improvement in dosimetry technologies. Furthermore, we have types of films which are used in film dosimetry. First one is radiographic film, which consists of protective layer, emulsion layer, and polyester base, which can be seen in figure 1. So emulsion layer is where the silver halide located, and it is very sensitive to the light. So the photon interaction can reduce the silver ion into silver atom. The deposition of silver atom can create darkening of film. So another film is radiochromic film. There are mostly two types of radiochromic film, which are different in chemical composition, plastic support, material, and size of sensitive element. So containing chemical compounds that change the molecular structure when there is radiation interactions. The changes of colors, which we can say in another term, that is polymerization, occurs when there is photon interactions. The color change corresponds to the radiation dose received. So another film is photographic film, which consists of silver halide that is similar to almost radiographic film. So it is commonly used in film baz, which we can see in figure 2. Now we can look into working principle of film dosimetry. In the first picture, there is construction of film, which may be a single emulsion and double emulsion. And just below of that picture, we can see their gelatinous matrix where silver halide is kept. In the second picture, it shows the microscopic interactions of silver halide with radiation. So we can see their valence band, band gap, and conduction band. Radiation stimulates the electrons, and electrons are jumped to conduction band. Due to some process, it falls down, and there is the formation of silver ion, which we can say sensitivity spec. In the third picture, after some process, there is formation of you know so many number of silver atoms, which further forms a latent image. After this, there is film processing. After film processing, densitometer can count optical density or darkness of film, and it will quantify. It will give numerical value as dose measurement, which is the result of analysis of calibration curve as optical density. So densitometer gives the numerical value that individual received as radiation dose. Furthermore, we will summarize the working principle in another slide. Now we can summarize the working principle of film dosimetry. So in the first phase, we have radiation interaction. When ionizing radiation penetrates the film, it disrupts the bonds between silver and halide atoms, leaving behind free silver atoms. So in the second phase, latent image formation. The more radiation the film is exposed to, the more silver atoms are liberated, which creates a latent image within the film, invisible to the naked eye. So in the third phase, which is bringing the image to light, during film processing, chemical reagents react with silver atom, hence darkening of film. That means optical density occurs. The degree of darkening is proportional to the amount of radiation deposited in the film. And the final phase is readout. That means quantifying the radiation dose. Densitometers measure optical density converted to dose using calibration curves, translating it into a numerical value representing the absorbed radiation dose. In this slide, for the information, we can see into examples of film. So there are so many examples of film, like gap chromic XRQA2 film, gap chromic MDV3 film, ESD-V2 film, FWT60 film, EBT3 gap chromic film, B3 film, gap chromic SD-V2 film, gap chromic EBT XD film, methyl thymol blue dye, that means MTB film. So all films has their own dose range, like you can see in the picture.
Hi everyone. So regarding the dosimetric properties of the film dosimeter, firstly, a useful dosimeter must exhibit the properties of high accuracy and precision. So accuracy means that it specifies the proximity of the mean value of the measurement to the true value. Meanwhile, precision specifies the degree of reproducibility of a measurement of the film dosimeter. Next is the sensitivity. Film dosimeter is sensitive to environment, so if the environment gives a high temperature and humidity, it will create fading. Moreover, film dosimeter has less readout convenience, which means it needs to be processed first and read later on. The third property is the dose rate dependence. So film dosimeter can be used to measure radiation only from 100 microgray to 15 gray, and the minimum dose that can be measured by film batch is 100 microgray, which means if the value less than 100 microgray, the dose is not able to be measured. Next is energy dependence. The sensitive component of the film dosimeter, the silver bromide crystal, contains a high Z material, which is the silver. So, for a given exposure, the optical density is greater for low energy photons than for higher energy photons, which can be seen from the figure below. This means that the calibration factor, which relates the optical density to the absorbed dose, varies with the photon energy. As such, film dosimeter must use some method to estimate the energy of the photons to which they are exposed to. For directional dependence, In some cases of film dosimeter, the filters on the front of the batch and those on the back have different shapes, for example like square or round shape. So as a result, the image of the filter on the developed film can identify whether the exposure was from the front or back. For example, like figure below, if the exposure is from the front, it will give a square images. Meanwhile, if the exposure is from the back, it will give a round images. And the last dosimetric properties is the spatial resolution. Film dosimeter gives excellent 2D spatial resolution, and in a single exposure, it provides information about the spatial distribution of radiation in the area of interest or the attenuation of radiation in intervening objects. So, since the dose is a point quantity, the dosimeter should allow the determination of the dose from a very small volume. The position of the point where the dose is determined, which its spatial location, should be well defined in the reference coordinate system. So, film dosimeter have excellent 2D resolution, where the point measurement is limited only by the resolution of the evaluation system. That's all from me. So I will pass to the next presenter.
Hi everyone, since the films available recently cover a wide range of doses from milli-gray to hundreds of gray, therefore different types of film can be employed in many applications. First of all, the film dosimetry can be used in quality assurance QA. The QA is divided into machine and treatment plan verification. For example, the radiochromic film can be used to quality check the X-ray tube for general radiography, CT scanner, mammography, and the remote afterloader in brachytherapy. Moreover, the QA in treatment plan verification, the radiochromic film can be placed on the acrylic phantom to verify the treatment plan in the patient-specific QA. Next, the film dosimetry enables the in vivo dose measurement in external beam radiation therapy using the high-energy photon, electron, and ion beams, as different types of radiation can interact distinctly in the human body. In addition, the dose measurement using the film as a dosimeter in different treatment planning techniques such as IMRT, BMAC, SRS, SBRT, brachytherapy, and IGRT is commonly applied. After that, when there is a new installation of linear accelerator, film is useful in commissioning procedure to measure the depth dose, beam profile, symmetry, flatness, and penumbra of beam. All this information of beam that emitted from linear is important to be installed in the computer for later treatment planning. This is because the film dosimetry provides a reasonable, accurate, and precise 2D distribution of exposure. In the figure 3, the left figure refers to the PDD curve while the right figure shows the beam profile. However, in research and education field, the film dosimetry allows the students to understand the radiation concept and effect. Meanwhile, this also provides hands-on opportunity in the research project as the film is easily to be handled by the students. Moreover, the film can be used as dosimeter, which is called film batch that contains film holder and film pack. In the film holder, there is filters to attenuate certain types of radiation. Different degree of darkening at the filter enable the differentiation of radiation type because the gamma ray and the X-ray can be attenuated at the copper or lead filter, while the plastic holder can attenuate the beta particle. For film pack, the photographic film consists of two emulsions with different sensitivities. So, the emulsion with large silver halide grain is sensitive to the exposure. Later, the emulsion with small silver halide grain is insensitive. Here, figure 4 shows the picture of the film batch. Lastly, the film dosimetry can be employed in high-dose industrial applications such as medical device sterilization, food irradiation, radiation hardness QA, and beam diagnostic. The radiation hardness refers to the ability of material in withstanding the ionizing radiation without experiencing significant degradation in their performance or functionality. The beam diagnostic refers to the analysis of characteristics and properties of the radiation. There are many pros and cons in film dosimetry. First, let's talk about the advantages of film dosimetry. First of all, the film is considered as a very thin and small dosimeter. Moreover, the film is relatively cheaper than a TRD. Since the film can be cut into various sizes, therefore all the small films can be placed at various points simultaneously for quick measurement. Hence, this shortens the measuring time. After that, the film can produce permanent record as it can rescan using the scanner. Next, the film can measure various types of radiation such as X-ray, gamma ray, and beta particle except for neutron. Later, the film can produce only 2D dose distribution. Moreover, the film is suitable for small field dosimetry as it can be cut into smaller sizes. Lastly, the film can display better spatial resolution after the single exposure. On the other hand, the film shows some disadvantages. Firstly, the film is known as passive dosimeter as it does not provide instant readout. Moreover, the film requires additional procedure to get the reading. For example, the radiographic film needs to be processed in dark room, while radiochromic film requires scanning using the densitometer. Later, the film requires calibration to get the calibration factor for every batch of film. Next, films show energy dependence characteristic. It is more sensitive to low energy photon due to high possibility of photoelectric effect in the film. In addition, the film is sensitive to environmental factor. For instance, the radiographic film is sensitive to light, temperature, and humidity. Lastly, there is a study proof that the film is orientation dependent, meaning that the orientation of film facing the radiation source needs to be considered in the dose measurement.
Assalamu alaikum wa rahmatullahi wa barakatuh. Greeting everyone. I am Sarah Talal Sulaiman al-Tarauna, Master Student in Radiation Science, and I want to complete when and why film dosimeter preferred over other dosimeters. At the first, film dosimeter are preferred in certain radiation monitoring applications due to their advantage. Mention them is necessary in evaluating cases of preference, like high spatial resolution, customizable shape, weak energy dependence, real-time dosimetry, wide range for doses, easy of use. Okay, at the first, high spatial resolution. Film dosimeters can provide accurate dose measurement with a high spatial resolution, making them suitable for application requiring precise dose distribution information. Customizable shape. Film dosimeters can be designed to fit the shape of experimental geometry, allowing for more accurate doses measurement in complex situations. Real-time dosimetry. Film dosimetry can be used for real-time dosimetry, providing fast and highly accurate measurement for gamma and X-ray dosimetry applications, and wide range for doses. Film dosimetry cover a wide range of doses from a few milligray to several hundred kilogray, making them suitable for various applications in radiation physics. Easy of use. Film dosimeters can relatively easy to use and can be customized to meet specific needs. Now, when film dosimeters preferred over other dosimeter, common application for film dosimetry I will mention. At the beginning, personal dosimetry. We can use it it in routine monitoring for workers in industries like healthcare, nuclear power, and aviation. Film dosimeters is preferred due to cost-effective way to track cumulative radiation exposure over a period, typically a month or a quarter. 2. Exceptional exposure assessment. In situations where workers may be exposed to low but potential harmful levels of radiation, film dosimeters offer a permanent record for regularity, compliance, and potential future health claims. And emergency response film badges can be pre-distributed to emergency respondents and quickly deployed in case of radiation accident. Assess individual exposure levels. And environmental dosimetry, we can use it in radiation mapping. Film dosimeters can be placed in strategic location to map radiation levels in an area over time, useful for environmental monitoring or post-accident cleanup. Cultural heritage protection for artifacts sensitive to radiation. Film dosimeters can be placed inside display cases or storage facilities to monitor cumulative exposure and inform appropriate preservation methods. The space exploration film badges are used in space mission to monitor astronauts' exposure to cosmic radiation and ensure their safety during prolonged missions. Other specific uses, we can use film dosimetry in brachytherapy. Film dosimeters can be inserted alongside implement used in brachytherapy to measure the radiation dose delivered to the target tissue. And calibration and validation. Film dosimeters are often used as reference dosimeters for calibrating and validating other types of dosimeter, ensuring accuracy in dose measurement. Also, we can use it in training and research. Film dosimeters can be used for training purposes in radiation safety program and research studies to evaluate radiation exposure in various scenarios. While film dosimeters may not always be the most evidence option, their cost effectiveness, long shelf life, and ability to provide permanent record make them a viable tool in various situations. The choice between film and other dosimeter type ultimately depends on specifics, need, and properties. Thank you for your listening.
These are the references that we use to prepare the presentation slide. That's all from Group 10. Thank you, everyone.